there are two questions, right? The first question is, why should you care? So you know information extraction in digital libraries can be beneficial. Moving from a textual representation of publications to a more structured representation, entities, relationships, and so on can help retrieval, can improve retrieval, allow complex question answering via Shankwell or something like that. So can be cool. And the next question is, what is nearly unsupervised? So you know there are these supervised methods. You need label training data. You need this sentence is a true relation, this is not a true relation, and you learn the patterns. Unsupervised mean you extract it basically based on the grammatical structure. And what we call nearly unsupervised is a combination of two methods. In the first method, we just use existing unsupervised extraction methods. So to convert a sentence like the JCDL conference 2022 is held as a hybrid conference or hybrid event in Cologne, Germany. Then we obtain this triple structure, so subject, verb phrase, object phrase, and then we do filtering. We see where are important concepts that are of interest in our domain, so like the conference name, the location, and then we do filtering and reduce the extraction to this filtered representation. Last year, we shared a toolbox for that on JCDL, and the main idea is, okay, give us two vocabularies, your concepts of interest, so entity vocabulary, and a few words for relations, then we can go from a textual representation to a knowledge graph. Last year, the session share asked an important question, so we just evaluated the toolbox for the biomedical domain in the last year, and obviously, the question was, okay, what does it mean in practice? So how much expertise and effort do we need in practice to apply such workflows? Is it worth the cost to go in this direction? Or should we stay and simply collect training data, right? And how generalizable are the methods? You state they are good for biomedicine, but do they work for political science, for example? So really important question. And the last question is, we can do the extraction, but what are we missing in practice? And this is what I'm trying to answer in this paper. And in this talk, I do not have any numbers for you. It's just a collection of qualitative findings. If you're interested in numbers, please read my paper. What have we done? We have performed 3 case studies, so 3 persons, 3 case studies, and 3 different domains. We selected the Wikipedia text because it's a descriptive writing and you have good vocabularies, right? Vocabularies about awards, like Nobel Prizes, about persons, and so on. Pharmaceutical domain, because we are the specialized information service for pharmacy. And in joint cooperation with the guys below there, behind there, so the specialized information service for political sciences, we looked at this domain. The main challenge there is it's basically focused on topics and events, and you likely do not have good vocabularies available. So how far can we go in such a domain? We tried different methods, so basically entity detection methods, extraction methods, and cleaning methods. How can we clean an extraction? So given the open information extraction and given the entity annotations, so they are marked bold, we have 4 different filter options. We can say we do not apply any filter. Okay, then we just do unsupervised extraction. Boring. We can do a partial filter and say, okay, there's this JCDL conference in the subject. So this could be the entity as a subject. And Cologne, Germany is mentioned in the object. So maybe the object is Cologne, Germany. And then we end up with the extraction. JCDL conference is held Cologne, Germany. This is a partial filter. The exact filter means that the whole subject phrase must be matched against one entity and that the whole object phrase must be matched against one entity. Can work if your phrases are short, but if you have such a large phrase, like in this example, we have no extraction. Bad. And what we developed new for this paper was a so-called subject filter. In practice, you often see sentences where something like, Albert Einstein won a Nobel Prize in physics, so and so on. So you have a very small subject and a large object clause. And this filter allows you to reduce subjects to entities and keep the original object phrases. So you can, for example, list all actions that were performed by the EU in the last years, or all actions that were performed by Albert Einstein. So can be practical. Yeah, well, what did we learn? Yeah, we have two different methods which we investigated for entity linking. So basically, we derived vocabularies from Wikidata, Mesh, and so on, and performed the dictionary-based entity linking. If your terms are precise, like for drugs and plant families, works really well. Persons also work well. Large events work well. But short terms, which may refer to a plethora of different concepts, not so good. Then you have many incorrectly linked homonyms, and this can be a problem. And especially if you use, for example, Wikidata to deduce these vocabularies automatically, you have many problems there. On the other hand, so Stanford Stanza is one latest tool for named entity recognition, works really well for persons, organization, countries, and so on, but you do not have precise entity identifiers. So Albert Einstein is one concept, A.Einstein is one, A.Einstein is one concept, but you do not know that both refer to the same concept. Could be problematic, and such tools may struggle with bad metadata. Some abstracts were in uppercase and the tool just crashed. For information extraction, we looked at two tools. I think OpenIE6 was introduced 2020 at the May, I think EMNLP, so an NLP conference, and on their benchmark it was very, very good, so good quality. What we see, short, simple sentences, it worked really well. But as sentences get long, you run into the following problem. Either your object phrase is very short and you completely miss the remaining context information of the sentence, or your object phrase is very long and you do not know how you can filter it. So what should we do then? If we do the partial filter, we maybe mess up the information. Bad. And one other observation is these tools are trained on the grammatical structure of sentences. So if you have a sentence, Hermann Kroll presents a paper, works. But if you have a sentence like the German book Känguru Chroniken, and you want to extract that German is the language of the book, it's not mentioned in a verb phrase. And then these tools may struggle because the information is simply not available. A different methods which we investigate was path-based information extraction. Given two entities in a sentence, we perform the dependency path of the sentence, so the grammatical structure. And if they are connected via verb phrases or some special keywords, then we do an extraction. Metformin is used in a treatment for diabetes. Treatment could be a word of interest for us, then we do the extraction. They are connected via this phrase. Very simple, works well if your relations are directed, so person received award, drug treats disease, good. Works really bad if your sentences are very long and your relations are undirected. So if you have a disease which could cause another disease, then you sometimes mess up the direction and this is bad, so then you do not know which one causes the other. Main advantage here is you can specify a list of words of interest for your domain. So for pharmacy, we could say therapy, treatment, I don't know, some methods, and then we could do some easy extraction with the methods, with the method. Yeah. Summary filtering. If you do no filter, then you can simply do unsupervised information extraction. So you do not retain any precise semantics here. No advantage. The partial filter is very interesting for simple sentences because it worked well there. But if your sentences get longer and your known phrases, so your extractions are getting longer, then you maybe find the location, but the complete phrase is ignored. And then you mess up the information. Could be a problem. The exact filter retained a really, really good quality because the complete noun phrases must be matched. But in practice, your recall is very bad. So for example, we had, I don't know, 10,000 abstracts from political science and we end up in 200 extractions. Not so good. And what we have observed is that this subject filter is very interesting in practice because you filter and you canonicalize your subjects, so you retain these actions were performed by Albert Einstein. These are the positions of the European Parliament, for example, and you completely retain the original object phrase, so you can generate semi-structured overviews. Yeah, you do not have a complete knowledge base in the end, but you may have lists of actions that you can map to some concepts, and this could be beneficial indeed. For the canonicalization procedure of verb phrases, we developed an iterative algorithm. So the basic idea is you do your unsupervised extraction, you have a database available, and then you can see which verb phrases have been extracted. So aids, prevents, treats, for example, and then you ask domain experts to map these phrases to some relations. So for example, say that aids could point towards a treats relation, and then this mapping is applied, you update your database, and you see the unmapped terms. In addition, you can use a word embedding to deduce some synonyms automatically to improve this procedure so that you do not have to specify all 1,000 terms. For example, for pharmacy, we need to specify around 60 terms in this vocabulary, and it was quite suitable for our retrieval service. Worked well for special words like tweets, award, received, member of, fine. But if you have words like do, publish, use, you do not have the sentence context, and then it's hard to map them. So it's a problem in the end. It's a really big problem. Strongly depends on your domain. Coming back to our research questions, what have we done? So for our pharmaceutical domain, we had around 9 sessions with 2 pharmaceutical experts, and we were able to build the corresponding vocabularies. So drug, disease vocabularies, and we could build a relation vocabulary to allow this retrieval service. So user can state information he needs as graph patterns, and we can match them against literature. For POLOX, political sciences, we were able to extract semi-structured knowledge, and for Wikipedia, we were able to extract some relations like award received, for example. It's quite easy, straightforward, but you quickly can have first results. How generalizable are the results? These methods have a moderate precision, but a strongly limited recall. Important to know. You should do the filtering. It's very important to retain your precise semantics, but you need the entity detection for it. If your entity detection is good, you have a good quality in the end. If your entity detection is bad because no vocabulary is available, you run into several problems. And this canonicalization of verb phrases is still challenging. Some verbs work very well, some verb phrases does not work at all. What's missing? It's like we argued in the talk on Tuesday, so the context of information is very important today. If you extract a cause statement from biomedical paper, you should be aware about the context conditions, and that is why we argue to keep the original paper information. What should you do? You need entity detection. If you do not have entity detection, this is not the paper you're looking for. If you have short and simple sentences, they work really well. If you have long sentences, use only the exact and the subject filter. The other filters are not good. If your relations are not expressed via verb phrases, consider Partha-E. But if the relations are not directed, then you will probably need supervision. And this brings me to the end of my talk. So I really believe that these unsupervised workflows are worth of studying in digital libraries. You can extract statements with them, and they allow you to bypass training data in the extraction phase completely. You do not need any labeled sentence at all. And this could allow novel access paths to digital libraries. But you must be aware that you need extensive filtering in practice, and this could be in some cases as expensive as labeling training data. So thank you for your attention.
Let's join hands to